Hello guys, welcome back to the channel. In today's video, I will show you how to secure your users' data when working with Node.js. Security is an important part of most backend applications, especially one where authentication and authorization is required. I will mostly focus on symmetric encryption in this video. Make sure you stick around to the end because I have got an exciting challenge for you. If that makes sense to you, then absolutely smash the like button. Ensure you subscribe to the channel to get access to all of our videos in the future as they drop. There are third-party libraries that can do all of the things you will learn in today's video, but we cannot always rely on them. And in today's video, I will show you how to reliably secure your users' data without needing any third-party library, starting with how we can securely hash a user's password, how we can securely verify a hashed password, how we can create a JWT from scratch, how we can verify a JWT, and last but not the least, how we can decode a JWT. First, let's start with how we can hash a user's password. I'm going to import createHash from the crypto library, and then I will create a password variable which is equal to test1234. Then I'm going to create a hash variable which stores the result of calling the createHash function with an argument of SHA-256. And this SHA-256 is going to be the encryption algorithm that is used to hash our password. I'm going to chain a call to the update method with the password. Then I will call the digest method to digest it into a hex. In fact, I will change this to a function that accepts a text argument which is a string so that this is reusable. You should always follow this pattern in your code. I will console log the result of calling the hash function with the password variable. Now, let's run the app from the terminal by running node index.cs so we can get live reload. You will observe that each time we run the hash password function, we will get the same hash back. And this is one of the drawbacks of using this method. Now, you might ask yourself, what are we trying to achieve here? We are trying to create a hash function we can use to securely hash users' password. I know we have the bcrypt library for that, but what if we had to engineer things from scratch and make sure that it is secure? Let's move on. You can see that this implementation is not very ideal because our users' password are at risk. What we might do next is to introduce a sort that will randomize the hash that is generated each time. I will create a variable sort which will be equal to the result of calling the random bytes function, which can be imported from the crypto library. We will call the random bytes function with 16 and convert it to a hex string. I will console log the sort, then I will pass the text and the sort to the update method, chain to the createHash function. And now you can see that each time the function runs, a new sort and a new hash is generated. You might ask yourself, how do we validate the user's password later? Let's append a period, then the sort to the string that is returned from calling the createHash function after we digest it. And now you can see that the string has a period and the sort appended to the hash. This way, you can further convert it to a single hex string which you can save. The next thing we are going to see is how to validate the user's password. Bear in mind that this is not our final code. We are just getting there. I will not advise you to use this method in production, and I will show you a more secure and reliable way for you to hash and verify your user's password. So make sure you stick with me to the end. I'll create a variable verify hash, which is equal to a function. This function accepts a user text argument, which is a string, a stored hash argument, which is also a string, and inside of this function, I will create a new hash. Then above the new hash, I will obtain the sort from the stored hash by splitting the hash based on the period and taking the item at the second index, which is 1. We will use the sort to construct the new hash just like we did when we were creating the hash from scratch. And after that, we will return a check that validates the new hash plus the sort is equal to the stored hash argument. Then we verify this function by console logging the verify function with the password test1234 and a hash which I will copy from the console. Normally, this would come from database. You can observe that we get through in the console that the passwords match. Let's look at a more secure method to create a hash from a password and also a secure method to verify a hashed password. We will import pbkdf to sync from crypto. The crypto.pkdf to sync method in Node.js provides implementation of the password-based key derivation function too. This function is used to derive a cryptographic key from a password, a sort, iteration count, key length, and digest algorithm as input. It applies the PKDF2 algorithm to generate a derived key. It operates synchronously, meaning it blocks the execution of the thread until it is complete. This function accepts 5 parameters just like as we said: the password which we want to hash, that is the password to derive the key from. This can be a string, a buffer, a type array, or a data view. The next argument is the sort, which is a random value used to prevent rainbow table attacks. It should be unique and at least 16 bytes long. The next argument is the iteration, which is the number of iterations to perform, and the higher the iteration, the more secure our hash is going to be. The next argument is the key length, which is the desired length of the derived key in bytes. Then last but not the least, we have a digest argument, which the HMAC digest algorithm used on the string. I will create a function hash password which accepts an argument password. I will create a sort by calling random bytes with 16.toString and store the result in a variable sort. Then I return equal to pbkdf to sync, passing in the password as the first argument to the function, followed by the sort, then 100,000 as the number of iteration. The key length will be 64, and then the digest will be SHA-512. I will chain equal to the toString method with hex and append the string returned to the sort. In between the string return and the sort, I will make sure that I put a period. Then I will console log the hash and result of calling the hash password function with test1234. And you can see that we get a randomly generated hash. Each time this function runs, we'll always get a random hash. Now let's see how we can verify a password against the hash. First, we are going to create a function named verify password, which accepts a password argument, which is a string, and a hash password argument, which is also another string. And then I will create a sort by splitting the hashed password based on a period and obtain the last item in the array. Then we will recreate the hash by calling the pbkdf to sync with the password argument, the sort. The number of iterations will be 100,000 like in the last instance. The key length will be 64 and the digest will be SHA-512. I will return equal to timingSafeEqual, with the first argument being a buffer that is created from the new hash, a period, and the sort, while the second will also be a buffer from the hashed password. The crypto.timingSafeEqual function in Node.js is designed to compare two buffers, typed array, or data views in a way that prevents timing attack. Timing attacks exploit the fact that comparison can take slightly different amounts of time depending on the data being compared. This can leak information about compared values. Crypto.timingSafeEqual mitigates this by ensuring that the comparison takes the same amount of time regardless of whether the input values are equal or not. It does this by performing a constant time comparison, meaning that execution time does not vary based on input data, thus preventing attackers from inferring information about the values being compared. You can see that the passwords match. Now we are done with how to securely hash and verify a hashed password. Let's see how we can create a JWT, okay? And for this, I'll revert back to the createHash function because at the end of the day, you don't want to store any sensitive information in a JWT, okay? So let's see how we can create a JWT from scratch. First, I will import the createHash function from crypto, and then I will create a type payload, which is a record type, and each key on the payload will be a string, while the value of the key can be of any type. Then I will create another type header, which has an ALG property, which is a string, and a type property, which is also another string. I will create a function createSignature, which accepts three arguments: header, which is a string, secret, which is also a string, and a payload, which is another string. And inside the function, I will return a call to the createHash with SHA-256 as the hashing algorithm, and then we will add the secrets and chain a call to the update method to update the hash with the header and the payload and digest it into a base 64 string. I will create another function, sign, which accepts two arguments: secret, which is a string, and payload, which is of type payload. Inside the function, I will create a variable header, which is of type header. The algorithm property will be HS256 and the type will be JWT. Then I will create an encoded property, which is equal to the result of calling buffer.from JSON.stringify with the header and converting it into a base 64 string. I will also encode the payload just the same way we did to the encoded header, and then I will create a new variable signature, which is equal to the result of calling the createSignature function and passing in the encoded header as the first argument. The secret becomes the second argument and the encoded payload becomes the last argument. Finally, I return a string that contains the encoded header, then a period, followed by the encoded payload, followed by a period, and then the encoded signature. I will test this out by calling the sign function with test1234 as the key, and then a random object with an underscore ID property as the payload, and console logging the results out to the terminal, I can see that we get back the JWT string. Now, let's see how we can decode this. I will create a function verify which accepts a token as a string, a secret as a string. Inside the function, I will split the token based on a period and store the results inside of a variable path. I will make a check that throws an error invalid token if the path does not contain 3 items. Then I will destructure out the encoded header, the encoded payload, and the encoded signature from the path array. I will use all this to create a new signature, and if the new signature is not equal to the encoded signature, I will throw another error, invalid signature, and return from the function. There's just one more thing to do, which is to decode the token. If you have been paying attention, then this should be pretty easy. I'm going to let you figure it out from here based on what you've learned from this video and from our previous videos on buffer. So that's going to be it for this video, guys. You've learned how to securely hash your user's password, how to securely verify a hash password. Now you've seen how to create a JWT from scratch, how to verify a JWT, and I believe you've also learned by yourself how you can decode a JWT. In our next video, hopefully on Node.js, we are going to look at asymmetric encryption and how to protect data that needs asymmetric encryption, as what we have looked at in this video is symmetric encryption. I hope you found this video useful, and if so, absolutely smash the like button. Ensure you subscribe to the channel to get access to all of our videos in the future as they drop, and I will see you in the next one.